Good evening, guys. Welcome back, and we are live now. So let's discuss today's problem. Solve the problem today. If you have not seen the problem, if you have not solved the problem, please pause the video, solve the problem yourself, and then come back here to see the solution. Like this is done to make your problem-solving skills a bit better every day, and 1% better every day. Okay, that's what our aim is at Cheenta. Okay, so let's get started, guys, and let's see the problem. The problem today is based upon the joint distribution. If you have not seen the problem, again I'm telling you, if you have not seen the problem, pause the video, see the link of the problem on in the description below. If it's not there, you can just pause the video over here and see the problem and then stop it and solve it yourself and then come back here again to see the solution later on. Okay, so now that to those who have seen the problem and solved it and have come here to check the solution, let's check it. So it's a joint distribution problem, and the problem revolves on a very basic fact about understanding whether a fx comma y, a joint distribution, is a real function f of x comma y is really a joint distribution or not. Okay, so that's the basic idea. It's just verifying whether a function f of x comma y is joint distribution or not. That's it. So let's get started, guys. Let's get started with the concept over here, and yeah. So the function is given like this, that f of x comma y is given to be 1. I think it's piecewise defined. It's going to be 1 if x is x plus 2y greater than or equal to 1 and 0 otherwise. So the concept that you need to understand in this are the following, that you need to understand first of all, what is f of x comma y? It's actually probability capital X is less than or equal to x and capital Y is less than or equal to y. This is the joint distribution, okay? And this is what the probability is. So if you understand that this is the definition of this, we will explore certain things, certain properties of the joint distribution. So if you try to draw the diagram, if you draw the diagram of x and y and see what this means, it's essentially this x axis is the y axis. That means given a point x comma y, we are sort of understanding, measuring the probability that the given outcome will lie in this region, in this marked region. Okay, that's what this probability is calculating. Like that's what this is probability is. The probability is lying in this marked region. Okay, probability of our outcome will be in this marked region. That's what the f of x comma y is. Okay. So this is the basic idea. Okay, this is what joint distribution is all about. Why this we are taking this to be joint distribution, that's a different thing altogether. But the main idea is that this is the probability. Okay, now it's given that the probability. So let's understand this. It's asked whether it's a joint distribution or not. So it's given here the probability is. So let's draw the region. So let's draw x plus 2y greater than or equal to 1. That means that x. So this is the idea. X by 1 plus y by half is greater than or equal to 1. That means this is the line. So line what? X plus 2y is equal to 1. So this line is x plus 2y is equal to 1. It's telling that for for numbers, for x and x comma y outcome in this region, in the above region here, where x plus 2y is actually greater than or equal to 1, this above region, its value is 1, and this below region, in this region, the probability of such a square formed by this, it's telling that probability of, if you take any point here, it's telling that if you take any point here, let's say here, then the probability of this entire region, so already the outcome of this entire region, outcome lying in the center region is 1. And it's also telling that if you take a point over here in the x plus y less than 1, the probability of that outcome region, probability of the outcome lying in this is 0 in this entire stuff. So this is the basic idea. This is the basic thing about the distribution function of two variables. Okay, this is what it's a very important basic concept. So it's x plus, this region is x plus 2y greater than or equal to 1. How can you check that? If you don't remember that, you just take a point. Okay, Just take a point over here, infinity comma infinity, infinity comma infinity. It must be either greater than equal to 1 or less than 1. So it's greater than 1. Okay, that's the basic idea. Okay, perfect. So now let's understand this. So we need to understand whether it's a joint distribution or not. So first is that, does it define a probability? Okay, so there are various properties of joint distribution. Okay, so let's check the properties of joint distribution. I will not go to the entire details, but I will just crawl to the properties of the joint distribution, two variable. The properties of joint distribution of two variable are the following. Okay, are the following. These are the various basic properties of joint distribution of two variables, and this is very important to know. So it's f of x comma y. So we can find the marginal distribution just by putting x is equal to infinity or y is equal to infinity. Okay. So if we put x is equal to infinity, f of x comma y is just 1. Okay. That's, is it a valid distribution function? What do you think? If you just put x is equal to infinity. So let's check all the properties over here. If you put x is equal to infinity, limit x tends to infinity f of x comma y, if you put that over here, you will see that it will be 1 because x is equal to infinity. So x plus 2y must be greater than or equal to 1 for any given y because x is equal to infinity. Okay, so therefore this must be going to 1. This is the very easy wala stuff, very easy stuff. So but this must be what? This must be the CDF of x. This was the marginal CDF of x. So fx is equal to 1 cannot be the marginal or can be the marginal CDF. No. Why? Because x tends to minus infinity is not 1. That is if fx comma y. Okay, I'm so sorry. This is the marginal PDF of y. So if you take, so this marginal PDF of y is equal to 1 everywhere. This is not a CDF. Marginal CDF. I'm so sorry. I'm just telling wrong words. So first what we do, we will take limit x tends to infinity. So if we take limit x tends to infinity f of x comma y, we get the marginal PDF or CDF of y. It's equal to 1 because for all x comma y, because if you fix y, even if you fix y, there exists an x which makes it really larger than 1. So if you fix y, you take x to be 1 minus 2y. Okay, and x tends to infinity. So you take any x greater than or equal to 1 minus 2y. So it will be f of x comma y is equal to 1 because f of x comma y is equal to 1 if x plus 2y is greater than or equal to 1. So therefore we are getting that limit x tends to infinity is equal to 1. That means we are getting the marginal CDF of y is equal to 1 for all y. And this is not a CDF. Why? Because limit x y tends to infinity minus infinity is not 0. So this is not a CDF. Okay. So this is one sort of way of proving that it's actually not a valid bivariate CDF. Okay, that's the one way of proving it. Similarly, since it's similarly, you can do it for marginal CDF of x also. If you do f of x comma y limit x tends to infinity, y tends to infinity, it's going out to be 1. That's very true. If you do limit x tends to minus infinity comma y, if you do limit x tends to minus infinity comma y, that will turn out to be also 0. Okay, you can easily check that. That's the homework. And this is actually one other condition. So let me share with you this other idea of disproving that it's actually not actually disproving or rather proving the fact it's actually not a valid CDF. You can use it by this method that you have already shown by the marginal CDF method that it's actually not a valid PDF, a CDF. I'm so sorry. So what you can show is that let's try to find out. So what is this probability x less than or equal to 2? So what it's telling that we can rewrite this probability lying in a square region. So what you can share here, that probability lying in a square region looks like this. So I will share with you the diagram. So you can share here that it's very interesting, and these diagrams are super important to know and understand. So you can actually tell here that probability x comma y lying in this rectangle, that is probability x less than or equal to x2 and greater than or equal to x1, and y less than or equal to y2 and greater than or equal to y1, this probability is actually nothing but this region, probability of x less than equal to x2 minus y less than equal to y2 minus this region. So it will turn out to be this simple fact. I will share the final result with you, this fact. You can just check it by normal geometrical method of area, square areas, and this like subtraction and addition. Okay, that's it. So you can check this exercise. Okay, so we can find out in terms of probability lying in a small rectangle. You can find out in terms of the CDF, and that's the result over here. I'm not explaining why. It's your work. Do the homework. Why it's true, but this is the result. Now understand that let's try to find out for various regions of such rectangles. So let's say the rectangle, so x plus y is equal to greater than equal to 1 ke liye, so this line is there. So here x plus 2y greater than equal to 1, and here x plus 2y is less than 1. So here it's 0 f of x comma y, and here it's 1 x of x comma y, right? So let's take a rectangle of this form. This is rectangle number 1. Let's take a rectangle of this form entirely here, rectangle number 2. Let's take a rectangle of type 3 entirely on this side, rectangle number 3, and let's take this side. Okay. So let's understand this. Iska le lo. Iska understand f of x comma y for all the corner points are 1. So therefore, the probability of this will be 0. Probability of this line here is 0. Okay, you can check it out. Why? Probability, let's say it's A, B, C, D. So if you just check it out, or x1, x2, x3, all of them will be 1, right? These are all the corner points, right? These are all the corner points. This point, this point, this point, and this point. So all of them are 1, so it will cancel out each other. So the probability of every rectangle lying in this region is 0. Similarly, it's same over here. All of them are 0, so probability that any point will lie inside this rectangle is 0 here. Again, by the same idea. So therefore, let's take a cross-sectional rectangle. So you will see, let's take this. This is a line, so let's take this type of rectangle. Let's say this type, there will be difference, okay? You will see the difference. Let's take this type, 2 of them are there inside on that other side. Let's take all the 3 of them are there on the other side. Okay? These are the only possibilities. 1 here, 2 here, 2 here, 1, 3 here, 1 here, 1 here, 3 here. 2 of them on this side. It can also be possible like this. Okay? So you can find out the probability in each one of them, and that's a food for thought for you. You can find out the probability in each one of them. You will see for this point, it's the probability less than or equal to this region is 1. This point ke liye is also 1. This point ke liye it's also 1. This point ke liye it's 0. So the entire probability will be this. Check it out. This minus this. So this plus this two are minus, and this is plus, right? So therefore, if it's 1 over here, it's 1 over here, this two are minus, this is 1, this is 0, so it's 1 plus 0 minus 1 minus 1. So it's becoming minus 1 negative. Let's take it 1 over here, it's 0, 0, 0 over here. So 1 plus minus minus plus, so it's coming out to be again 1 here for this one. The probability of an outcome lying in this region. And similarly, if you're not understanding, if you're joined late, please watch the recording from the beginning. For here it's 1, 1, 0, 0. For here it will be 0. You can check it out. Plus 1, minus 0, minus plus 0. Okay, so it's actually the same thing. So understand for this one, for this type of region, it's turning out, you can check it out, that for this type of rectangle, where 3 of them are lying on this side, where it's 1, the probability is coming out to negative, minus 1, which cannot be possible because probability is always greater than or equal to 0, non-negative. So this is also a different way of proving that it's actually not a valid CDF. Okay? This is also a different way of proving it's actually not a valid CDF. So we have proved it in 2 different ways. If you have joined late, please don't see the solution. please don't see the solution, and you can actually solve this out, stop it, and then solve it yourself, and then come back and check your solution. Okay, that's the basic idea. So all the best, guys, and all the best, guys. And you can check, and use this main two properties, one, two, and the last property over here to show that actually on a valid CDF. Okay. So all the best, guys, and I will see you in the next video. Stay tuned and stay blessed. If you are liking this solve idea problem idea, please do like and share and comment your ideas, different way of solving problems. And please do subscribe to our channel for more such everyday video and for notifications of such lives and discussion of solutions. All the best, guys, and yep, do check out our website. We have our students have done an extremely really dedicated and hard work to get really good results on IIT Jam and ISI CMI data science this year. So do check out and do support their hard work. Yeah, do check out the results and support their hard work. All the best, guys, and have a really good evening. And see you soon in the next video. Bye bye. Stay tuned and stay blessed.